Hello everyone, this is the short introduction video of our KDD 2025 paper, Hyperparametric Influence Minimization, Feature-Driven Intervention Beyond Blocking. Information diffusion is an important phenomenon in our digital and increasingly interconnected society. For instance, in a social network, information, say a tweet, may spread, often by viral dynamics, following a viral diffusion model. In the right context, a tweet may spread to huge audiences in a very short lapse of time. Information diffusion may be very helpful in many contexts. For example, in advertising or in online public awareness campaigns. For such cases, we study algorithms to maximize spread. The bulk of the literature on diffusion networks focuses on maximization. However, it may also be very harmful. For example, the spread of misinformation online is one of the major challenges of our society today. And in such settings, we study how to minimize spread, and that is the problem we focus on here. But information diffusion is not at all limited to social media. Just as tweets are viral in the blogosphere, failures are viral in energy grids. They are contagious. They have a tendency to spread to the point that they may start small and ultimately lead to large blackouts. This is yet another example of harmful diffusion. And there are many other examples of applications that can be modeled by diffusion networks and phenomena by which information may spread virally. How we get such diffusion models and diffusion networks in practice. We can learn, extract such diffusion networks from observed spread, from so-called cascades. In the energy grid case, we can build a failure diffusion graph, which models how anomalies may propagate from two important dimensions of the data: the history of cascading failures, and the underlying physics knowledge, like the features of transmission lines or other components. In the most common models, a diffusion graph is a directed graph where each edge is labeled by a probability value, the probability of contagion on that edge. Continuing with the energy grid example, nodes in the learned diffusion graph would correspond to transmission lines in the physical grid, and such a diffusion graph will be different from the physical grid since anomalies are known to jump non-locally. For contexts where diffusions can be harmful, we study in this paper how to minimize spread. This boils down to choosing optimally, under certain budget and other constraint, the interventions changes in the diffusion medium such that the risk of large diffusions is reduced. For instance, in practice, we may want to contain the spread of misinformation in social media by helping certain users to filter better the data they repost. Or we may want to mitigate the risk of cascading anomalies in an energy grid by improving the load capacity of certain critical transmission lines. Join us for our paper presentation in Toronto. We look forward to seeing you there. And in the meantime, spread the word on this very exciting upcoming conference.